Alright, so in this video, we'll be solving the Stats 1 May June 2024 guest paper. If you haven't watched the video where I explain how we came up with this paper, go watch that one first. But anyways, subscribe and let's get into it. Number 1. The following back-to-back stem and leaf diagram represents the monthly salaries in dollars of 27 employees at each of two companies, A and B. Okay, part A says find the median and the interquartile range of the monthly salaries of employees in company A. Alright, so let's start with finding the median Q2. So to get the median position, we can say n plus 1 over 2. In this case, n is 27. So that's 27 plus 1 over 2. And this is 28 over 2, which is 14. So this means that our median is in position 14. So let's count up to position 14. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we've got $2,710 for Q2. We can say that this is 2,710. And then now we need to also find our interquartile range, and we know that that's Q3 minus Q1. Now to get the position for Q3, we can say 3/4 of n plus 1. N is 27, so 27 plus 1. So this is 3/4 of 27 plus 1. That gives us 21. Okay, 21. So that means we need to count 21 positions. So for Q2, we counted up to 14, so we can continue from there. That's 15, 16, 17, 18, 19, 20, 21. So this means that Q3 is equal to 2,840. Now let's find Q1. To get the position of Q1, that's 1/4 times 27 plus 1, which would give us 7, Q1. So let's just change the color and count the first 7 positions. So that's 1, 2, 3, 4, 5, 6, 7. So that's 2,610. Alright, let's go back to our blue pen. So we can come here and say that our interquartile range is equal to Q3, which is 2,840, minus Q1, which is 2,610. And let's punch that into the calculator. This is 2,840 minus 2,610, and that gives us 230. So we can conclude that for part A, our final answer is that Q2 is $2,710 and our interquartile range is $230. Now let's move on to part B. So we're given that the lower quartile, median, and upper quartile for company B are 2,600, 2,690, and 2,780 respectively. Part B, draw 2 box and whisker plots in a single diagram to represent the information for the salaries of employees at companies A and B. Alright, so to be able to draw a box and whisker plot, we need 5 pieces of information. We need to know what the minimum value is. We need to know what the Q1 lower quartile is. We need to know what the median is, the upper quartile, and finally the max value. Okay, so let's start with company A. If we go to the stem and leaf diagram, we can tell that the smallest value here is 2,500. So that's 2,500. And then Q1, Q2, and Q3 we evaluated in part A. So Q1 is 2,610. Q2 is 2,710. And then Q3 is, if I can find it, it's over here, 2,840. 2,840. And then let's go back to our stem and leaf diagram to get the maximum value. The maximum value is here, and that is 3010. 3010. Okay, now let's do the same for company B. So the minimum value, let's go find that from our stem and leaf diagram. That's 2540. So this is 2540, and then Q1, that's the lower quarter, we were given to be 2600, and then Q2 2690, and then we've got Q3 2780. Then let's get the maximum value from the stem and leaf diagram. That's 3090. Okay, so this is 3090. Now that we have all this information, we can finally draw our box and whisker plot. So let's draw our x-axis here. This will represent monthly salaries, I believe. Monthly salaries, and this is in dollars. Okay, and we need to create a scale. So what's our lowest value here? That's 2500 over here, and then our largest value is 3090. Okay, so we can move in 50s. Let's try moving in 50s. So we'll start here and say that this is 2500, and we'll go to 2550. We'll go to 2600, and we'll go to 2650, and then we'll go to 2700, then 2750, 2800, 2850. This is 2900. Okay, so let's expand our x-axis here. So we want it to be a bit longer. So this here would be 3000, and then 3050, and then 3100. Okay, now we can start. Let's start with A. We're saying that our minimum value over here is at 2500, so that's gonna come over here. Let's draw it here, and then we go on to Q1, which is 2610, which would be somewhere here, and then we go on to Q2, which is 2710. That would be somewhere here, and then Q3 2840 right here, and then the max value 3010. That should be there. And now let's draw the box. Okay, and then we also need to draw our whiskers, and this is the box and whisker plot for company A. Let's do the same for B. So we're starting at 2540. 2540 would be somewhere here, so that would be there. And then we're going to 2600. 2600 is over here, 2600, and then we're moving on to 2690. 2690 should be somewhere here, that, and then we've got 2780. 2780 should be somewhere here, that's Q3, and then finally 3090. 3090 will be all the way over here. And now let's draw a box. like that. And then our whiskers. And this is the box and whisker plot for company B. We have completed part B. Now let's move on to part C. It says comment on whether the mean would be a more appropriate measure than the median for comparing the given information for the two companies. Alright, when we talk of mean, in the calculation for mean, we include all the values, but if you go to company B, you notice that we have a value here, the max value for company B, this 3090. We consider that an extreme value, and so that's going to inflate our mean and make our mean look bigger than it is. So in this case, the median would be more appropriate, and you would conclude that median is more appropriate, is more, let me scroll up, is more appropriate, as mean is unduly affected by extreme value, and we can point out what the extreme value is. Extreme value for company B, and we'll put it in brackets, that value being 3090. And this would be our final answer, and we have completed question number 1. Let's look at question number 2. Jay and his wife Kaz are having a party. Jay has invited 5 friends and each friend will bring his wife. Part A. At the beginning of the party, 12 people stand in line for a photograph. Part I. How many different arrangements are there of the 12 people if Jay stands next to Kaz and each friend stands next to his own wife? Okay, so that would look like this. We've got Jay standing next to Kaz. These two are in a block of their own. And then we've got friend 1 together with the wife. And then we've got friend 2 together with their wife. And we'll repeat this, friend 3 with their wife. And we've got friend 4 with their wife. And then friend 5 with their wife. Okay, so let's start by counting the number of boxes that we have. We've got 1, 2, 3, 4, 5, 6. We can rearrange these boxes in 6 factorial ways. Okay, so that's the first part. And notice that within each box we can actually swap the order of the wife and the husband so that the wife actually comes first. So for example, in the first box this would look like K and J. So for that reason we have to multiply by 2, and this also happens in the second box. So this would be wife 1 and friend 1, so we'd have to multiply by 2 again. So instead of multiplying by 2 by 2 by 2, we just simply count the number of boxes we have 6, and then we raise it to the power 6. And let's evaluate that using a calculator. That is 6 factorial by 2 to the power 6, and that gives us 46,080. And this would be our final answer for A part 1. Let's move on to part 2. How many different arrangements are there of the 12 people if Jay and Kaz occupy the 2 middle positions in the line, with Jay's 5 friends on one side and the 5 wives of the friends on the other side? Okay, so we're supposed to have Jay and Kaz in the middle, right? They have their own block in the middle, and then we're told that we want the friends on one side. So let's put the friends on the right hand side. So we've got friend 1, friend 2, friend 3, friend 4, friend 5, and then on the other side we've got the wives. So we've got wife 1, wife 2, wife 3, wife 4, and wife 5. Okay, so we've got Jay and Kaz in the middle, and then we have the wives on one side and the friends on one side. So let's find how many ways we can rearrange the wives on their side. So since there are 5, that would be 5 factorial. And then let's find how many ways we can rearrange the friends on their side. That's also 5 factorial. And then notice that they have not specified that the wives should be on the left hand side of J and Kaz and the friends on the right hand side. So that means we could actually swap these two so that the friends are on the left hand side and then the wives on the right hand side. For that reason, we have to multiply by 2. And then for J and Kaz, we're also not told who's supposed to come first. So this means we could also write this as K and J, with Kaz coming first and J coming second. And for that reason, we multiply by 2 again. So now let's punch this into the calculator. That's 5 factorial times 5 factorial times 2 times 2. And that gives us 57,600. And this is our final answer for A part 2. Now let's move on to part B. For a competition during the party, the 12 people are divided at random into a group of 5, a group of 4, and a group of 3. Find the probability that J and Kaz are in the same group as each other. Okay, so for J and Kaz to be in the same group, it means they are either in the group of 5. So we'll say, in fact, let's just write it as G5. They are in the group of 5, 1, 2, 3, 4, 5. So we've got J and Kaz, and then the group of 4 is here 2, 3, 4, 1, 2, 3. Or they're in the group of 4, which means we've got the group of 5 having no one, and then the group of 4 as J and Kaz, and then the group of 3 is empty. Or the third scenario is that they could be in the group of 3. So this is the group of 5, group of 4, and then group of 3, and 2 slots are taken by J and Kaz. Okay, so let's find the number of selections in which J and Kaz are in the group of 5. So remember that these are 12 people, and we've removed J and Kaz from those 12 people, which means that we have 10 people remaining. And in the first group here, we've got 3 slots, so it's 10 choose 3. And when we choose 3 people, we subtract them from the 10, so that means we have 7 remaining. And now we are choosing from, or we're choosing into 4 slots. And we subtract those 4 from 7, and now we have 3 remaining, and we're choosing them into 3 slots. And then we can do the same. So let's evaluate this using the calculator. That's 10 choose 3 times 7 choose 4 times 3 choose 3, and that gives us 4,200. Okay, and then let's evaluate the scenario in which they are in the group of 4. So again, we've already removed J and Kaz from the group of 12, meaning that 10 people remain. And in this case here, we're choosing them into 5 slots. So that's 5 times, subtract those 5 from 10. That becomes 5 choose. In this case, we only have 2 slots in that group. So that's choose 2. And if you subtract the 2 from 5, you have 3. Choose, we have 3 slots in here. So that's choose 3. And let's evaluate that. That's 10 choose 5 times 5 choose 2 times 3 choose 3, and this gives us 2,520. And now the scenario in which J and Kaz are in the group of 3. So again, we've already removed them from the 12 people, so that means we have 10 people that we're choosing into these 5 slots. So choose 5 times, subtract the 5 from 10, so we've got 5 choose. In this case, we now have 4 slots over here, so 5 choose 4, multiplied by, if you subtract the 4 from 5, that becomes 1, and we're choosing that one person into this 1 slot. So if we evaluate that, that's 10 choose 5 times 5 choose 4 times 1 choose 1, and this gives us 1,260. Let's add all those up. 4,200 plus 2,520 plus 1,260, and this gives us 7,980. So these are the selections in which J and K's are together. Now we want probability. So to get the probability of J and K's being together, we're going to divide the number of selections in which J and K's are together by the total number of selections when there are no restrictions. So that would look like this. We've got the group of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3. And we're selecting, we've got 12 people to start with. So in this group here, we've got 5. So it's 12 choose 5. If you subtract the 5 from 12, it now becomes 7 choose. In this case, we've got 4 slots. And then if you subtract the 4 from 7, you remain with 3. So it's 3 choose. You have 3 slots here. So 3 choose 3. If you punch that into the calculator, that's 12 choose 5 times 7 choose 4 times 3 choose 3. And this gives you 27,720. So these are the total number of possible selections. So now to get the probability of J and K's being together, we're going to divide this by this number. So that's 7,980 over 27,720. Let's punch that into the calculator and we get 19 over 66. And this would be our final answer. Let's move on to question number 3. Tim has 2 bags of marbles A and B. Bag A contains 8 white, 4 red, and 3 yellow marbles. Bag B contains 6 white, 7 red, and 2 yellow marbles. Tim also has an ordinary fair 6-sided die. He rolls the die. If he obtains a 1 or 2, he chooses 2 marbles at random from bag A without replacement. If he obtains a 3, 4, 5, or 6, he chooses 2 marbles at random from bag B without replacement. Part A. Find the probability that both marbles are white. Okay, so if we want both of the marbles to be picked to be white, we're looking at him picking bag A and then 2 white marbles, or picking bag B and then 2 white marbles. Okay, so for him to pick bag A, he has to roll either a 1 or a 2, and the chances of that happening are 2 out of 6 since it's an ordinary die. And once he has picked bag A, the probability of picking a white marble is 8 out of, the total of marbles is 8 plus 4, 12 plus 3, 15 out of 15 multiplied by, since we've already picked a white marble, it means only 7 will remain, and this is sampling without replacement, so it's out of 14. And now let's go on to the bag B scenario. So for him to pick bag B, he has to roll either a 3, 4, 5, or a 6. So that's 4 out of 6. And then the probability of him picking a white marble in bag B is 6 out of 15. And since it's sampling without replacement, to pick a second white marble, it will be 5 out of 14. So let's punch this into the calculator. That is 2 over 6 by 8 over 15 by 7 over 14 plus 4 over 6 by 6 over 15 by 5 over 14, and this gives us 58 over 315, and that's our final answer for part A. Part B says find the probability that the 2 marbles come from bag B given that one is white and one is red. So this given here tells us that we're dealing with conditional probability. So our formula for conditional probability is the probability of x given y is equal to the probability of x intersection y over the probability of y. So let's define our events. X is the event that the 2 marbles come from bag B, that's event X. 2 marbles, bag B. 2 marbles come from bag B. Y is the given event. 1 is white and 1 is red. So we've got 1 white, 1 red. And then X intersection Y is that marbles are from bag B, marbles from bag B, and 1 is white, 1 is red. Okay, and what we need to find is the probability of X intersection Y. So that's the probability of the marbles being from bag B, and 1 being white and 1 being red. Okay, so the probability of X intersection Y is equal to the probability of picking bag B and then white and a red, or alternatively we could pick bag B and then pick the red marble first and then the white marble first. We have to consider both scenarios since they haven't specified which marble is being picked first. Okay, so this would be X intersection Y. Probability of picking bag B, we already say that is 4 out of 6. 4 out of 6. And then picking a white marble out of bag B, that is 6 out of 15. Now this is sampling without replacement, so the total marbles would be 14. And then we have to consider how many red marbles are in bag B. We've got 7, so that's 7 out of 14. Plus the probability of picking bag B, that's 4 over 6, multiplied picking a red marble, that is 7 out of 15, 7 out of 15, plus picking a white marble now we have 14 marbles remaining, and picking a white marble from bag B we've got 6, so it's 6 out of 14. Okay, let's punch this into our calculator. Probability of X intersection Y is equal to, this is 4 over 6 times 6 over 15 times 7 over 14 plus 4 over 6 times 7 over 15. This should be a multiplication sign over here, times 6 over 14, and this gives us 4 over 15. This is the probability of X intersection Y. We also need to evaluate the probability of Y, and that's the probability of picking 1 white and 1 red marble. So what this means is that we could pick bag A and then a white and a red marble, or we could pick bag A and then a red and a white marble, or we could pick bag B and then a white and a red, or we could pick bag B and then a red and a white. So probability of Y is equal to the probability of picking bag A. We say that that is over here, that's 2 out of 6, so that would be 2 out of 6, 2 out of 6 multiplied by the probability of picking a white marble from bag A, so that would be 8 out of 15, 8 out of 15, and then a red marble, so we have 14 marbles remaining. How many red marbles do we have in bag A? We've got 4 red marbles, so it's 4 out of 14, 4 out of 14, plus the probability of picking bag A, that's 2 out of 6, followed by probability of picking a red marble, that's 4, and this is out of 15, multiplied by probability of picking a white marble. We have 8 of them, and the remaining marbles are 14. And then this section over here is basically what we evaluated when we were doing probability of X intersection Y, so that sums up to 4 over 15. So let's punch what we have into the calculator. This is 2 over 6 times 8 over 15 times, that's 4 over 14, plus 2 over 6 times 4 over 15 times 8 over 14 plus 4 over 15, and this gives us 116 over 315. Now that we have the probability of the intersection as well as the probability of y, we can get the probability of x given y, and this is equal to the intersection 4 over 15 divided by 116 over 315. So if we punch this into the calculator, 4 over 15 divided by 116 over 315, that gives us 21 over 9. So probability of x given y is equal to 21 over 29, and this is the final answer. Alright, so let's move on to question number 4. A fair six-sided die has the numbers 1, 2, 2, 3, 3, 3 on its faces. The die is rolled twice. The random variable x denotes the sum of the two numbers obtained. Part A, draw up the probability distribution table for x. Okay, let's start by drawing a possibility space diagram. So this will be our horizontal axis. This is the first row of the die, and then we've got the second row of the die. So the faces are 1, 2, 2, 3, 3, 3, and then that's the same on this side, 1, 2, 2, 3, 3, 3. Okay, we are told that x denotes the sum of the two numbers obtained. So that means to get the variable x, we're going to simply add. So for example here, so this would be 1 plus 1, that's 2, and then 1 plus 2, that's 3, plus 2 again, that's 3, 1 plus 3, that's 4, so that's 4, 4. Then let's move on to 2 plus 1, that's 3, and then 2 plus 2, that's 4, and then 4, and then 2 plus 3, that's 5, 5, 5, 2 again, so it's exactly the same, 3, 4, 4, and then 5, 5, 5. Now on to 3, 3 plus 1 is 4, plus 2 is 5, 5, 3 plus 3 is 6, 6, 6, and that's the same, yeah, 4, 5, 5, 6, 6, 6, 4, 5, 5, 6, 6, 6. Okay, and now we can draw our probability distribution table. Okay, so we have x and then probability that x is equal to x. So let's draw the cells here. And what are the possibilities that we have? We've got 2, 3, 4, and 5, 6. 2, 3, 4, 5, 6, 2, 3, 4, 5, and 6. So the probability of getting a 2, we've got, let me pick a different color. So we've got a 2 here. That's 1 out of our total possible outcomes are 36. And then the probability of picking a 3, that's 1, 2, 3, 4. So that's 4 out of 36. Probability of picking a 4, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 36. And then a 5, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 36. And then a 6, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 36. And this would be our probability distribution table. Okay, part B says find the expectation of x and the variance of x. So let's start with expectation. Expectation of x is equal to that summation of x times p. So expectation of x here is equal to 2 times 1 over 36 plus 3 times 4 over 36 plus 4 times 10 over 36 plus 5 5 times 12 over 36 plus 6 times 9 over 36. Alright, let's punch this into the calculator. That's 2 times 1 over 36 plus 3 times 4 over 36 plus 4 times 10 over 36 plus 5 times, that's 12 over 36 plus 6 times, that is 9 over 36, and this gives us 14 over 3. So the expectation of x is 14 over 3. Now let's find the variance. var of x is equal to the summation of x squared p minus the expectation of x squared. So this means we need to first find the summation of x squared p. So the summation of x squared p is equal to, that will be 2 squared times 1 over 36 plus 3 squared times 4 over 36 plus 4 squared times 10 over 36 plus 5 squared times 12 over 36 plus 6 squared times 9 over 36. Summation of x squared p. Let's punch this into the calculator. 2 squared times 1 over 36 plus 3 squared times 4 over 36 plus 4 squared times 10 over 36 plus 5 squared times 12 over 36 plus 6 squared times 9 over 36, and this gives us 206 over 9. So this is 206 over 9. So that means the variance of x is equal to 206 over 9 minus our expectation squared, so 14 over 3 squared. var of x is equal to, so this is 206 over 9 minus 14 over 3 squared. That gives us 10 over 9, and this is our final answer. Let's move on to question number 5. A children's wildlife magazine is published every Monday. For the next 12 weeks, it will include a model animal as a free gift. There are 5 different models: tiger, leopard, rhinoceros, elephant, and buffalo, each with the same probability of being included in the magazine. Sahim buys 1 copy of the magazine every Monday. Part A. Find the probability that the first time that the free gift is an elephant is before the 6th Monday. Right? Now this word, this first time, means that we're dealing with a geometric distribution. So if you hear the word first, or if you hear until, we're dealing with geometric. So let's start by defining our random variable x, which is the RV, number of Mondays until free gift is what? Is an elephant. And we know that x follows a geometric distribution, and the probability of success is, we've got 5 different animals. We've got a tiger, a leopard, rhinoceros, elephant, and buffalo, and we're told that each of them have the same probability. So that means the probability of picking an elephant is 1 in 5. So that's our probability of success. And we're saying the first time that the free gift is an elephant is before the 6th Monday. So that's the probability that x is less than 6. Okay, so we can write this as the probability that x is less than or equal to 5, which allows us to use the idea that probability that x is less than or equal to r is equal to 1 minus q to the power r. So we can come here and say that this is 1 minus Q is the probability of failure, which is 4 over 5 to the power R is 5 in this case. So the probability that X is less than or equal to 5 is equal to, that's 1 minus 4 over 5 to the power 5, and this gives us 0.672. And this is our final answer for part A. Let's move on to part B. Find the probability that Sahim will get more than 2 leopards in the 12 magazines. Okay, so now we're trying to figure out how many leopards Sahim will get in 12 magazines. We have now fixed the number of trials. This means we're now looking at a binomial distribution. So we're saying Y is the RV, number of leopards that Sahim gets. And we know that Y follows a binomial distribution. Our number of trials are 12, and the probability of getting a leopard again is 1 in 5. And we are looking for the probability that Y is. We want the probability that Sahim will get more than 2 leopards, so greater than 2. And we can calculate this by saying 1 minus the probability that Y is less than or equal to 2. And let's use the formula for binomial probabilities. So this is 1 minus, we'll start with 12, choose 2 times 1 over 5 to the power 2 times 4 over 5 to the power 10. And then we're adding 12, choose 1 times 1 over 5 times 4 over 5 to the power 11, and we are also adding 4 over 5 to the power 12. And let's close our bracket and let's punch this into the calculator. So this is 1 minus, let's open our bracket, then we have 12, choose 2 times 1 over 5 squared times 4 over 5 to the power 10, and this is plus 12, choose 1 times 1 over 5 times 4 over 5 to the power 11 plus 4 over 5 to the power 12, and let's close our bracket. This gives us 0.442, and this is our final answer for part B. Part C, find the probability that after 5 weeks, Sahim has exactly one of each animal. Okay, so let's write it up here. Sahim can either get a tiger or a leopard or a rhino or an elephant or a buffalo. And we're saying after 5 weeks, we want him to get exactly one of each animal. So the probability of getting, let's say he gets a tiger in the first week, there's a probability of 1 in 5 or 0.2. And then to get a leopard next week, that will also be 0.2. To get a rhino next week is 0.2, elephant 0.2, buffalo 0.2. So since there are 5 of them, we can raise this to the power of 5. Now notice that here we've just assumed that the order he gets the models in are tiger, leopard, rhino, elephant, buffalo. But this can also change. We can also rearrange this in 5 factorial ways. And so that would mean our answer would be 0.2 to the power of 5 times 5 factorial, and that gives us 0.0384. So this is 0.0384, and this would be our final answer for part C. Number 6. The lengths of western bluebirds are normally distributed with mean 16.5 centimeters and standard deviation 0.6 centimeters. A random sample of 150 of these birds is chosen. How many of these 150 birds would you expect to have lengths between 15.4 centimeters and 16.8. Okay, so let's define our random variable. Let x be the random variable length, and this is in centimeters, of western blue birds. And we know that x follows a normal distribution with mean 16.5 and our variance is 0.6 squared, and we want to find the birds with lengths between 15.4 and 16.8 centimeters. So this is 15.4 and then we've got 16.8. So let's standardize. That is 15.4 minus 16.5, and this is over 0.6, which is our standard deviation. Then z 16.8 minus, what's our mean, 16.5 over 0.6. Okay, let's punch that into the calculator. That's 15.4 minus 16.5 over 0.6, and this gives us negative 1.833. This is less than z, which is less than 16.8 minus 16.5, and this gives us 0.5. So if we sketch a bell curve, what we are looking at is we have a 0 over here, and then 0.5 would be somewhere here, 0.5, and then negative 1.833. We want this shaded region over here. So we can get that by saying phi of 0.5 minus 1 minus phi of 1.833. Okay, so read off the values from the normal distribution tables. That's 0.6915 minus 1 minus 0.9666. Let's punch this into the calculator. 0.6915 minus 1 minus 0.9666, and this gives us 0.6581. So this is the probability of a bird having a length between 15.4 centimeters and 16.8. Now we have been given a sample of 150 birds. We want to know how many of those we would expect. So that means we're going to multiply this by the 150. So if we do that, we get 98.715. So let's round up. That means we expect 99 bluebirds to have a length between 15.4 and 16.8 centimeters. Okay, so we're given that the lengths of eastern bluebirds are normally distributed with mean 18.4 centimeters and standard deviation sigma centimeters. It is known that 72% of eastern bluebirds have length greater than 17.1 centimeters. Part B, find the value of sigma. We're going to say let y be RV, that's the length in centimeters of the eastern blue birds, and y follows a normal distribution with mean 18.4 and variance sigma squared. We are given that 72% of these bluebirds have a length greater than 17.1. So the probability that y is greater than 17.1 is equal to 72%. So we're going to write that as 0.72. So we have to use this information that we have over here to get sigma. So let's start by standardizing. That would be z is greater than 17.1 minus our mean, which is 18.4, and this is over sigma, and this is still equal to 0.72. So if we simplify our numerator, that is 17.1 minus 18.4, and that gives us negative 1.3. So we've got the probability that z is greater than negative 1.3 is equal to 0.72. This should be over sigma. Okay, so now let's draw a bell curve for this. We're saying greater than, this should be 0. We want a region of 72%, and let's say that's negative z. This is the region that is 72%, 0.72. Okay, and we can tell that our z value over here is to the left side of 0. That's why I've put it with a negative sign. So to get this z value over here, we're going to say arc phi of 0.72, which basically means that we're reading the tables in reverse. And if you do that, the z value that you get is 0.583. And we can tell that from our sketch here, our z is negative, so this is negative 0.583. Now that z value is equal to this negative 1.3 over sigma. So this would become negative 1.3 over sigma is equal to negative 0.583. So that means sigma is equal to negative 1.3 over negative 0.583. Sigma is equal to, if we punch this into the calculator, we get, that is 2.23, correct to 3 significant figures, and that would be our final answer. For part C, you are given that a random sample of 120 eastern bluebirds is chosen. Use an approximation to find the probability that fewer than 80 of these 120 bluebirds have length greater than 17.1 centimeters. Okay, so let's define our random variable. We've used x, we've used y. Let's use e since we're talking about eastern bluebirds. Let e be the RV, the number of eastern bluebirds. And what are they saying about these birds? They are saying that find the probability that fewer than 80 of these 120 bluebirds have length greater than 17.1 centimeters. So number of eastern bluebirds with length greater than 17.1 centimeters. So we're already given the probability of an eastern bluebird having a length greater than 17.1%. That's over here. They said 72% of eastern bluebirds have length greater than 17.1 centimeters. And notice that we have a fixed number of trials, so this is actually being defined under a binomial distribution, and we can say that E follows a binomial distribution with n being 120, and then our probability of success is 0.72. Okay, we were told to use an approximation. In this case, this is at AS level, so we know that the only approximation we use is a normal approximation to the binomial distribution, but it's always safe to check that NP is greater than 5 and NQ is greater than 5 before actually using this approximation. So we'll actually do that in this case. So NP is equal to 120 multiplied by 0.72. Let's punch that into the calculator. 120 by 0.72, that's NP is equal to 86.4, and this is indeed greater than 5. Let's check NQ. NQ is equal to 120 times What's 1 minus 0.72? That is 0.28. 0.28, and that gives us 33.6, and this is also greater than 5. So we can say that use normal approximation to the binomial distribution. And we can go on to say that E follows a normal distribution with mean NP and variance NPQ. So E follows a normal distribution. Our mean NP we evaluated to be 86.4. So we write 86.4 over here. NPQ, let's evaluate that. That's 120 times 0.72 times 0.28. And let's punch that into the calculator. 120 times 0.72 times 0.28. And that gives us 24.192. So this is 24.192. Okay. And now the probability that we are evaluating is that fewer than 80 of these 120 bluebirds, so less than 80, probability that E is less than 80. But this question was defined under a binomial distribution, which is a discrete distribution. Now we have moved on to a continuous distribution. So this would mean E is actually less than 79.5 if we apply continuity correction. So this means that the probability that E, we are solving for the probability that E is less than 79.5. So let's standardize. This is Z is less than 79.5 minus our mean, which is 86.4, over our standard deviation, which is root 24.192. Probability that Z is less than, this is 79.5 minus 86.4 over root 24.192, and this gives us negative 1.403. Okay, and if we sketch a bell curve, we have 0 over here, and negative 1.43 would be 1.403 would be here, and we're looking for the less than region. So we can write this as 1 minus phi of 1.403. You can read off the value from the normal distribution table. That's 0.9196. So if we punch this into the calculator, 1 minus 0.9196, that gives us 0.0804, and this would be the final answer. And that is the end of the guest paper. If you enjoyed it, please leave a like and subscribe. Otherwise, thank you for watching. Bye bye.